Okay, so go to page 346 in your textbook. We're going to look at another example of a line in slope-intercept form. Okay, so page 346 says that submarines must withstand tremendous pressure exerted on them by all sides by the water when they're deep down in the ocean. This table right here tells us how the pressure changes on the submarine as it dives deeper and deeper and deeper. So to start off with, we have an initial pressure of 100 kilopascals. That would be at the surface, right? 0 meters, or a depth of 0 meters would be on the surface. And you'd experience 100 kilopascals there. You go down 25 meters and it's 350. Go down 50 meters, 600, and so on. Part A, asks us to just sketch the graph. Alright? So we're going to use this grid here to do that. We're going to sketch pressure versus depth. So that means that pressure, I'll just put P, is going to be on the y-axis, and depth, I'll put D, is going to be on the x-axis. And I want to scale the pressure so that I use as much of this graph as possible. So I go 0 here, and I'm going to go up by 100 every 2 squares. So it's 100, 200, 300, 400, 500, 600, 700, 800, 900. Put in my values, and 900. Good. And then the depth, we want to go up to 75, so I'll go up by 10s every 3 squares. So that's 10, 20, 70, and 80 should be high enough. Alright, let's graph these points. So 0, 100 is the first point we're going to graph. That should be right here. Again, that's the y-intercept. 25 and 350. Okay, so 25 over, 350 up. That would be, right, 25 over would be here. Up to 350 would be right there. Okay, so that's this point. And then 50, 600. 50 over, 600 up. Would be there, I think. Yep. And then 75 and 850. So 75 over, 850 up. That would be right there, I think. Yes. And then we ask ourselves, do we connect this line? Is it continuous? Well, of course it is, because you can't teleport from 0 meters depth to 25 meters depth to 50 to 75. That doesn't make any sense. So there is reasonable data in between our dots, therefore we connect. Okay, so draw a line through our dots. And there we go. Part B in this problem is asking us what the slope is and what it represents. So we can just use 2 points in this table here and use slope formula. So let's, sorry, my phone is going off here. Okay, let's do that. Let's use 2 points in our table and find the slope. Okay, so y2 minus y1 over x2 x minus x1. And let's just make this x1, this y1, and then this will be x2, this will be y2. Alright, so plugging those in, we get 350 minus 100 over 25 minus 0. And that will equal 250 over 25, which is just 10. Okay, so the slope of this line is 10. What does that represent? What does that mean in this problem? Well, it tells you the amount of pressure that you gain per meter that you dive. Okay, so every meter I go down, I gain 10 kilopascals of pressure. And that can build up quite a bit as you go deeper and deeper and deeper. So that's something to watch out for if you ever go scuba diving or submarine diving way down to the bottom of the ocean. Part C asks us to determine the value of the parameter b and what it represents. Okay, so b in this formula, you'll remember this value b is the y-intercept, and that is 100, right? We kind of got that from our table. That was nice. And like we were talking about before, this would represent the pressure at the surface, right? So this is the pressure at the surface. All right? Now for D. Okay? D says that the deepest point on Earth, whoa, is Challenger Deep in the Mariana Trench. This trench is located in the Pacific Ocean. In 1960, the research submarine Trieste reached the bottom of Challenger Deep, that's the deepest point on Earth, and at this depth, the walls protecting the 2 crew members had to withstand a pressure of, I'll write this down because it's astonishing, 109,300 kilopascals. Just think about that for a moment. Compare that to the pressure at the surface, which was 100. Now it's 109,300. Oh my goodness. What would happen if you were down there, right? Yeah, maybe it's a little horrific to think about that, but you probably wouldn't have time to think about the fact that you were being squished into a tiny little thing. I don't know if you'd be squished into a ball, but you would definitely die. Let's just leave it at that. Point is, what's the depth? How deep does the submarine have to go to get to that point? Well, let's see if we can use our equation to help us figure that out. Right? We knew that the slope was 10. We knew that the y-intercept was 100. And if we put that into our slope-intercept form, we get something that looks like this. We get y equals 10, the slope, x, plus 100, the y-intercept. Instead of using x and y, though, I'm going to use p for pressure. That's what y represents here. And d for depth. That's what x represents. And I want to know at what depth is the pressure this amount. So I'm going to put this value here for p. Okay, so I'm making a substitution here for p. 109,300 equals 10d plus 100. Change sides with the 100, change signs. So that's 109,300 minus 100 equals 10d. And so that's 109,200 equals 10d. And then we just solve by dividing both sides by d, or by 10, sorry. So this would give me a value of 10,920 meters. So you need to dive almost 11 kilometers to experience a pressure of 109,300. That's crazy.